Okay, I'm going to recap what we've already done in this chapter because we've done a lot. Normal CDF is used to find area under the normal curve between two z-scores. And we proved the empirical rule this way. We entered z-scores of -1 to 1, and we demonstrated that the area between them was approximately 68. And then we did the same for -2 to 2 and -3 to 3, and we proved those numbers that were stated in the empirical rule. We also used IMV norm to find a z-score given an area to the left. Now, for both these two bullets, if the question involves z-scores, then the mean on the calculator, the mean mu, is always specified as 0, and the standard deviation will be specified as 1. If the question involves finding z-scores or finding the area given z-scores. So mean is 0, standard deviation is 1. When the question involves raw scores instead of z-scores, we also use normal CDF, but the problem will provide us a mean and standard deviation other than mu is 0 and standard deviation is 1. We will be provided with a true mean and standard deviation for a data set. Now, when we use that true mean and standard deviation, we will be able to find the area between two raw scores using normal CDF. And we will be able to find the raw score on a horizontal axis using IMV norm. The concept of a percentile for applications with the normal distribution came into play. A percentile gives us the area to the left, and we use that to find z-scores, raw scores, and basically given a percentile we were able to find the given a raw score we were able to find its percentile rank. Okay, so on our calculator, let's remember that if the problem asks us for area, like area under the bell curve, or it asks us for the proportion, or it asks us for the number of data values, or it asks us for a percentile or probability, then we use normal CDF. The problem will provide as input either raw scores and a mean and standard deviation or z-scores. And if the problem gives us raw scores or z-scores and we are asked to find any one of these values here, we use normal CDF on our calculator, and normal CDF will provide to us some number between 0 and 1. And that number between 0 and 1 represents area, a proportion, or a percentile. The other type of problem, if the problem asks us for a score, either a z-score or a raw score, so it's asking us for some quantity from the horizontal axis. If the problem asks us for a score but provides area or a percentile or a proportion or probability, then we use IMV norm. And we get out of the calculator the raw score or the z-score, depending on what we entered for the mean and the standard deviation. Okay, so we've so far done problems of both types, but for the remainder of this chapter we're going to deal a lot with probability now. So we're going to do a few questions on probability. Probability is another application of the normal curve. Probability is proportion under the normal curve, which basically is the area under the normal curve. Since the entire normal curve represents 100%, pieces of the normal curve have to be less than 100%, which makes sense for probability because probability is always between 0 and 100%. A probability distribution for the number of minutes it takes a student to get to class was given like this. This is on our first lecture for Chapter 7. So we have the number of minutes it takes a student to get to class represented as a discrete number on the horizontal axis, and the height of each rectangle represented the probability that it would take a student X minutes to get to class. So the probability that it would take a student 6 minutes to get to class is 17%. And we could read the rest of the histogram in a similar way. To find the probability a student will require from 5 to 7 minutes to get to class, it's a matter of looking at the area between 5 and 7 and basically adding up the area of the rectangles between 5 and 7, which came out to be 0.45. But when we express our horizontal axis not as a discrete variable but as a continuous variable, we have smooth bell curves. So our smooth bell curve now no longer has rectangles associated with it, and between 5 and 7 we have this shape here that can no longer be approximated using area of rectangles. We have to use some other tool, and that's why we have normal CDF on our calculator. It enables us to find the area under the bell curve without using the calculus that's required for it. Okay, in general, the probability of an event E in a normal distribution is defined to be the proportion of area under the normal curve satisfying event E. So if we see a question in this chapter where we're asked for a probability of something happening, we simply have to find the proportion of area under the normal curve of that event happening. Okay, so for example, the horizontal axis is generally labeled here with variable x, but let's say our horizontal axis represents heights. And on the far left border we have a height of, let's say we're dealing with a height of 60 inches, and on the far right we're looking at a height of 66 inches. Hypothetically, the probability of finding a person with a height between 60 and 66 inches would be found by looking at the area here under the bell curve. This area would represent the probability that a person chosen at random has a height between 60 and 66 inches.